Hello everyone, today we're talking about limits, section 12.1 in our book. So the first example, we want to complete the table of values, and then we're going to use that table to estimate the value of the limit. So they want the limit as my x approaches 4. So what I've done here is I'm taking numbers very close to 4, right, that are a little bit bigger, and numbers very close to 4 that are a little bit smaller, and I'm going to see what those numbers seem to be converging to. So I'll go ahead and just plug these different values in for x. I'll plug a couple in so you can see exactly what I'm doing, and then I'll just fill in the rest. And then you'll see that as I get closer and closer to 4, my values, my y values are approaching a number. We call that the limit. So I'm going to go ahead and show you a couple values on the calculator, and then I'll go ahead and fill in the rest of the chart so you can see what's happening. So first, let's do square root of 3.9, and I like to fill it in with zeros because I know I'm going to use more places. And then parentheses all for the entire numerator, followed by parentheses for the entire denominator. And so there we see we get 0.252 if we round it. So again, I'll do the next one, 3.99. And if you aren't aware of this trick, second entry pulls that same back up. And now I just change this 9 and that's 0.2501 or 0.2502. So you can kind of see it there that as we get closer to 4, so at 3.9 we were at 0.252, at 3.99 we're at 0.2502, and then at 3.999 we're at 0.250. Likewise, when we're above 4, we get 0.24998, so very close to 0.25. And as we get a little bit further away, obviously we're getting a little bit further away from 0.25. But as we go from further away and go towards 4, we can see that I'm approaching 0.25 or 1/4. Okay, so that's what they mean by the limit as x approaches 4. A little bit tedious now to get that approximate value, but eventually we'll learn different techniques to get us to that limit. So one more example, they want us to use the table of values to estimate that limit. Okay, so the table of values I'd want to pick numbers just a little bit smaller than 1 and numbers a little bit bigger than 1. So I'm going to use 0.900, 0.990, and 0.999, and then 1.001, 1.010, and 1.100. There's another 0 there. Well, it doesn't matter if the 0 is there or not, it'll be the same value. So I go ahead and plug these in for x just like I did in the previous example, and I get 1.43, I get 1.493, and then I get 1.499. And if I go a little bit above 1, I get 1.501, I get 1.51, and I get 1.58. So we can see that as I go from further out and approach 1, that my y values are approaching 1.5. Or 3 as if we want. Okay, so I'm going to show you this graphically real quick to show you what I mean by approaching 1.5, what I mean by the y value, the limit approaching 1.5. So I'll go ahead and throw this in real quick. So our numerator, x cubed minus 1, and my denominator, x squared minus 1. So that gives us that value, all right, and I'm looking for as x approaches 1. So from the graph, it's kind of hard to see what value the graph is approaching when x equals 1, but if I go to the table, I can see at 1 there's an error, but there's definitely a value here, right? Because 1 obviously gets us a 0 in the denominator, so it looks like we don't have a limit, but hey, it looks like the line's continuous. So there's actually a hole right there at 1, but we can see that my lines are approaching 1.5 when x equals 1. So this is why we can't just look at the table or even look at the graph necessarily. We might need to come up with a table of values to determine what my limit is at a specific x value. Now they've given us a graph, and they want us to tell us if these given limits exist, and if not, explain why. So the first one, is there a limit as x approaches 3? So as I go from 4 towards 3, yeah, it looks like there's going to be a limit, and that approaches 2. All right, my y value is 2 as x approaches 3. Next one, as x approaches 1. So as x approaches 1, right, so as x approaches 1 from the negative side and approaches 1 from the positive side, looks like our y value is approaching negative 1. Right, as my x value is converging on 1, the graph is approaching negative 1. Now you may say, hey, the dot for when x equals 1, the point when x equals 1 is actually at 1. Yeah, but our graph is approaching, right, not at 1. I'm not worried about what the graph is equal to at 1. I want to know what my graph is approaching. And the positive and negative side are approaching negative 1. Even though the point when x equals 1 is at a positive 1. The limit is approaching negative 1. Next, I want when the limit approaches negative 3. So even though there's an open circle there, right, there's not a point actually at x equals negative 3. When x equals negative 3, we can see that my graph is approaching, right, and this is going to approach positive 1. Next, it wants when my graph is approaching 2 from the negative side. So as x approaches 2 from the negative side, right, so from numbers less than 2, that's what that little negative symbol above the 2 means. So if you can't see it very well, it's saying x approaches 2, and then it's got this negative symbol above the 2, meaning as it approaches 2 from the negative side. So as it approaches 2 from the negative side, it goes to 1, right? So as it goes here, all right, from the negative side, it goes to 1. From the positive side, which is the next one, as x approaches 2 from the positive side, so if it's got that extra operation up there, that just means from the positive or negative side. So as it approaches 2 from numbers larger than 2, right, we can see that, okay, the graph is approaching 2. So then, it wants the limit as just the graph approaches 2. Doesn't matter, and 2 is the composition of both sides. Okay, so as I'm approaching 2 from below 2 and above 2, we can see that these don't match up. They don't approach the same number. So when the negative side or the lower side of a value is not equal to where the positive side or the higher side of that value are approaching, then we say it does not exist. And it does not exist because both sides are not approaching the same limit, right? Their limits are not the same. So this, we would not have a limit when x approaches 2, even though we do have a limit when it approaches 2 from the negative side and approaches 2 from the positive side. We just do not have a limit if we're just looking to approach 2 from both sides. All right, and finally, graph the piecewise function, and then use the graph to determine if the following limits exist. So first, I'm going to take the function and go ahead and graph it. So my function says when x is less than 0, so strictly less than 0, my y equals 2. So if it were equal to 0, right, I'd have an open circle on my y-axis at 2, and then all values less than 0 for x means my line is going to look like that, always going to equal y equals 2. Next, I get the line x plus 1 if x is greater than or equal to 0. So if I plug a 0 in for x, well, I get a 1 back. So that's going to give me that point there, right? A 0 for x gives me a 1 for y. And I plug a 1 in, I get a 2, 2 in, I get a 3, 3 in, I get a 4, and you get the point. So that is my piecewise function defined by that function there. Now let's go ahead and see if we can answer some limit questions on that. So as I approach 0, as I approach my y-axis, right, as I approach when x equals 0 from the negative side, well, I'm approaching 2, right? In fact, it's always 2, but I'm approaching 2, right? Even though there's not an actual value at x equals 0 there because it's an open circle, I'm still approaching 2. So that limit as x approaches 0 from the negative side is 2. Then if I'm looking for the limit as x approaches 0 from the positive side, so as I'm approaching 0 from the positive side, I can see that I'm approaching 1. And since my x approaching 0 from the negative side and approaching 0 from the positive side are not meeting at the same point, then I do not have a limit of just strictly x approaching 0. Right, so from the negative side is not lining up with the positive side, so I do not have a limit as x approaches 0. So go ahead, try the example problems that accompany this in the PowerPoint, and we'll go over them in class tomorrow.